everyone, and welcome to today's lesson on measures of position. In this lesson, we will explore the essential tools that help us understand where data points fall within a dataset. Whether you are new to statistics or looking to deepen your understanding, you are in the right place. By the end of this video, you will be able to define and illustrate the different measures of position, quartiles, deciles, and percentiles, and understand how they are crucial in real-world applications. So, are you ready? Let's start learning. Are you familiar with the NCAE, or National Career Assessment Examination? It is an aptitude test geared towards providing information through test results for self-assessment, career awareness, and career guidance of junior high school students of the K-12 basic education program. Usually, this is given to grade 9 students of private and public high schools. This assessment is created to assess the skills of grade 9 students planning to proceed to senior high school toward providing relevant information on their skills, abilities, and readiness for academic and non-academic course. And of course, to provide information that will help high school students make wise career decisions. So, have you experienced taking the NCAE? If so, what was your score? Did you know your rank? Have you thought of comparing your academic performance with that of your classmates? Have you asked yourself why a certain examinee in a national examination gets higher rank than the other examinees? Moreover, when you go to college, some state universities and colleges are offering programs for graduating students who belong to the upper 5%, 10%, or even 25%. What does this mean to you? Okay, so for this lesson, that is what we will focus on. To begin, let's have the definition of the measures of position. When we talk about the measures of position, they are the techniques that divide a set of data into equal parts. So we have the three most common measures of position. We have quartiles, deciles, and percentiles. So let's start with quartiles. Quartiles are the points that divide the rank data into 4 equal parts. So in each data set, okay, there are 3 quartiles. Okay, so we have here first quartile, this one. So the first quartile is the value in the data set such that 25% of the data set is less than or equal to this value, and the remaining 75% is greater than or equal to this value. Moving on, second quartile or Q sub 2 is the value in the data set such that 50% of the data set is less than or equal to the quartile 2 value. And the remaining 50%, okay, is greater than or equal to this value. Quartile 2 is also known as the middle score of a given data set. Moving on, for quartile 3, it is a value in our data set such that 75% of the data set is less than or equal to our quartile 3 value, And the remaining 25% is greater than or equal to this value. So again, in a given data set, there are three quartile values that we have. Quartile 1, quartile 2, and quartile 3. Let's have an example. So consider this situation. A group of students obtained the following scores in their geometry quiz. 10, 12, 8, 14, 15, 9, 10, 12, 7, 12, and 6. So to solve this one, okay, let's say we are looking for the unknown quartile values, quartile 1, quartile 2, and quartile 3, which divides our distribution into 4 equal parts. So the first thing that we have to do is to arrange our values in our data set. It is helpful if we arrange our values in increasing order, though it's also right to arrange our values in decreasing order. The purpose why we are arranging our values in increasing order or ascending order or from least to greatest is for us to easily determine our quartile values. Okay? So this is now our arranged values. Our smallest value in our data set is 6 and our largest value is 15. So after we arrange our values in increasing order, we can now determine our quartile values. Okay? So let's begin with our middle value. Since there are 11 values in our data set, so the middle value is located in the 6th position. So we have here quartile 2 value is 10. And then the remaining 5 values in here, we get the middle value that will be our quartile 1 value. So there are 5 values left to the left of 10. So the middle of it is 8. So our quartile 1 value is 8. Then to determine the quartile 3 value, we have also to get the middle value, the remaining values to the right of 10. So the middle value, okay, here to the right of 10 is 12. So that will be our quartile 3. Okay, so in this case, as you can see, our quartile values 8, 10, and 12 divide our distribution into 4 equal parts. Okay? In this case, class, it's easy to determine the quartile values if we only have 11 values in our data set. But what if we have more or less? Okay? So to find for our unknown quartile value, we are actually using this formula. So we have Q sub k is equal to k times the quantity n plus 1 over 4, where Q sub k represents our quartile, k represents our quartile location, and n is our number of elements in the data set. But we will not explain this further for this lesson. We will explain this further in the succeeding lessons. Okay? So let's now proceed to the next measure of position, which is deciles. So deciles are the 9 score points which divide the distribution into 10 equal parts. They are deciles and they are denoted as d sub 1, d sub 2, d sub 3 until d sub 9. So we have here d sub 1, 2 up until d sub 9. As you can see, since deciles divide our distribution into 10 parts, each part or each division represents 10% of your data set. Okay, that's it. So let's have an example. A group of students obtain the following scores in their geometry quiz. So let's say for this problem, we are looking for the 5th decile. Okay, the 5th decile. Just like in quartiles, we also have the middle score in deciles. So for quartiles, what is again our middle score? Very good, quartile 2 value. For deciles, we also have a middle score, and that is our decile 5 value. So we will be looking for the middle score or decile 5 value in this data set. So for our solution, just like in quartiles, we have to first arrange our scores in ascending order from least to greatest. So we have here our arranged scores. 6 again is the lowest score and 15 is our highest score. So since we have 11 scores in our data set, okay, our middle value is located in the 6th position. So this is our 6th position, and this will be our decile 5 value 10. Okay, so actually there are also other decile values in this data set, but it cannot readily be seen because we have a small number of values in our data set. So as you can see in here, the arrows point where the remaining decile values are located. Okay. All right. So in the previous slide, you were able to see that not all decile values could be readily seen in our data set. So how do we find for those values, okay, not readily seen, or even those values seen in our data set? So just like in quartiles, we are also using a formula. So this is our formula. D sub k is equal to k times the quantity n plus 1 over 10, where d sub k represents our decile, k is our decile location, and n is our number of elements in our data set. So this is the formula used to locate the unknown decile values in the data set. Just like quartiles, this will be explained further in the succeeding sessions. And now we proceed to the next and for the last measure of position, which is the percentiles. Percentiles are the 99 score points, which divide a distribution into 100 equal parts so that each part represents the data set. Okay, so 99 score points. So percentiles are used to characterize values according to the percentage below them. So for example, for percentile, first percentile or P sub 1, it separates the lower 1% or the lowest 1% from the other 99%, okay, of the data set. Same through with the second percentile, it's located in here. It separates the lowest 2% from the 98%, and so on and so forth. So percentiles for the information, for your information, everyone, is commonly used in assessments here in the Philippines. Just like in the NCAE and the college entrance test in the form of percentile ranks. Knowing your percentile rank gives you the idea of your performance relative to the other test takers. Furthermore, this also means that the higher your percentile rank, the better you perform with respect to the other test takers, and the more likely that you will be admitted to your dream university or be accepted in the scholarship of your choice. Okay, now let's compare the different measures of possession. This time we will be looking into the interrelatedness of the different measures of possession. Now looking on the slide here, this shows the correspondence between the different measures of possession. Take note that quartiles divide our distribution into 4 equal parts. So each part in here represents 25% of our data set or our distribution. Decimals, on the other hand, divide the distribution into 10 parts. Okay, so there are 9 decimals in each data set. Each part in here corresponds to 10% of our data set or our distribution. And for the percentiles, okay, for the percentiles, they divide the distribution into 100 equal parts. So each part in the distribution represents 1% of our data set. So let's begin with quartiles and percentiles. Quartile 1 value is the same as percentile 25 value because 25% of the values in the data set falls below our quartile 1 and percentile 25 value. Moreover, quartile 2 and percentile 50 are of the same value as well because if a score falls on quartile 2 or percentile 50, 50% of the values in the dataset fall below quartile 2 or percentile 50 value. And the remaining 50% of the values in the dataset is above quartile 2 or percentile 50 value. The same argument follows for quartile 3 and percentile 75. They are also of equal value. So if a score falls on quartile 3 or percentile 75, it means that 75% of the data set falls below our quartile 3 or percentile 75 value. And the remaining 25% of the data set is greater than or equal to our quartile 3 or percentile 75 value. Okay. For decimals and percentiles, okay, we have here the following have the same values. Decimal 1 and percentile 10. Decimal 2 and percentile 20. Decimal 3 and percentile 30. Decimal 4 and percentile 40. Decimal 5 and percentile 50. Decimal 6 and percentile 60. Decimal 7 and percentile 70. Decimal 8 and percentile 80. Decimal 9 and percentile 90. So, for instance, a score falls on decimal 3 or percentile 30. It means that, okay, we know that each division corresponds to 10% of our data set. So, if a score again falls on decimal 3 or percentile 30, it means that 30% of the values in the distribution falls below decimal 3 or percentile 30 value. And the remaining 70% in here, okay, of the data set, okay, is greater than or equal to our percentile 30 or decimal 3 value. Furthermore, if a score falls on decimal 5 or percentile 50, it means that 50% of the values in the data set is less than or equal to our decimal 5 or percentile 50 value. And the remaining 50% of the values in the data set is greater than or equal to our percentile 50 or decimal 5 value. Okay. So that is how quartiles and percentiles are related to each other and also percentiles and decimals. We should also bear in mind that quartile 2, decimal 5, and percentile 50 are of equal value. They are considered as the middle score of every data set. Again, quartile 1 and percentile 25 are also of the same value, the same as true with quartile 3 and percentile 70. All right, let's have a sample problem for percentiles. So we have a group of students again obtain the following scores in their geometry quiz: 10, 12, 8, 14, 15, 9, 10, 12, 7, 12, and 6. So for this problem, we have to look for percentile 25, percentile 50, and percentile 75 values. So the first thing that we have to do, just like in other measures of position, we arrange the values in increasing order or in ascending order. So we have this. We know from the previous slide that the percentile 25 and quartile 1 values are equal. Percentile 50 and quartile 2 values are also equal. And percentile 75 and quartile 3 values are equal. Now we start locating the percentile 50 value or the middle score of this data set. So we have in here 11 scores in our data set. So our middle score is located in the 6th position. So our percentile 50 value or our middle score is 10. All right. Next, we look for percentile 25 value. The percentile 25 value is the middle value of the remaining values to the left of percentile 50. So we have in here 5 scores. So the middle value is 8. Okay, that will be our percentile 25 value. And for percentile 75, to get percentile 75 value, we have to get the middle value of the remaining scores to the right of percentile 50 value, which is 10. So we have here 5 scores left to the right of 10, and the middle value is 12. So this will be our percentile 75. As you can see, percentile 25, percentile 50, and percentile 75 divide our data set into 4 equal parts, just like how its corresponding quartile values do. So in the previous example, it's easy to locate percentile values because, again, we only have 11 values. What do we find for the other unknown percentile values given numerous values in our data set? So we will also be using a formula. So we have here P sub k is equal to k times the quantity n plus 1 over 100, where P sub k is our percentile, k is our percentile location, and n represents the number of elements in our data set. Okay. So this formula for percentile will be explained further in the succeeding sessions. Okay, class, it's a wrap. Let's now recap our lessons for today. So we recall again the 3 measures of position, starting with quartiles, deciles, and percentiles. So quartiles are the points that divide the rank data into 4 equal parts. Deciles, on the other hand, are the 9 score points which divide a distribution into 10 equal parts. And lastly, percentiles are the 99 score points which divide a distribution into 100 equal parts. And these are the formulas that we use in order to precisely determine the unknown quartile, decile, and percentile values. Again, this will be explained further in the succeeding videos. And this ends our lesson for today. Hope you've learned something, everyone. See you on the next video. Bye!